We're going to start this thing off with one of these activity slides, okay? So I'm going to do part one because it's pretty gnarly. It's a derivation. Part two, I'd like you to pause the video and try it yourself. You know, it's just doing some plug and check calculations, okay? So what does this whole thing say? Okay, express, so I just wanted to check that my pen was working. Okay, express the Vanderwaal equation of state as a virial expansion and powers of 1 over Vm and obtain expressions for B and C in terms of the Vanderwaal's parameters A and B. What? What did that say? Okay, let's break this down. So express the Vanderwaal equation of state. Okay, so we know we're doing that. So let's start there. Okay, express the Vanderwaal equation of state. Let's just write it down and see what that means. So I had to add a page at the end of these notes because I didn't leave myself enough room. Okay, so let's just write down Vanderwaal. And I'm going to write down the, with molar volume, so that's just one less variable to keep track of. Okay, so RT over Vm minus B minus A over Vm squared. Okay, so there's our Vanderwaal, right? So let's just go back and now read what the rest of the problem says. Express the Vanderwaal equation of state. Okay, we did it. We expressed it. As a virial expansion of powers of 1 over Vm. Okay, let's break that down now. Let's talk about what does that mean, this virial expansion and powers of 1 over Vm. Okay, so we know the virial equation, so let's go ahead and write that down. We have several different ways of writing it down, but one way I could write it down is P Vm equals RT and 1 plus, and that's going to go B over Vm. Okay, so then when we expand this, right, we know it's going to go plus C over Vm squared. And I could keep doing it, right, D over Vm cubed, E over Vm fourth, but rarely do we go past the square term in the virial equation of state. We don't need that amount of precision, okay? And then I'm also going to write down another definition that might help us out, which is the compression factor Z. P over Vm over RT is the compression factor, okay? And so now if I back up here and look at what this is asking me, let's read it again. Express the Vanderwaals equation of state as a virial expansion and powers of 1 over Vm and obtain expressions for B and C in terms of the Vanderwaals parameters A and B. So that's really the magic that we're doing. Obtain expressions for B and C in terms of A and B. That's what we're trying to do, okay? So now let's go back to that, okay? And let's see here. If I'm going to go ahead now and do some factoring in my Vanderwaal, like I'm comparing Vanderwaal here, and I'm comparing this here, and I can see like I've got some 1 over Vm's over on this side, and I've got some 1 over Vm's over on this side, okay? And so what I'm going to do here with Vanderwaal, I'm going to write it as P equals, and I'm going to factor out an RT over Vm, okay? And the reason why I'm going to do that is because up here, right, I can actually see that I can write this virial equation. So that's an R. Whoa, let's try that again. Okay. RT, right? So all I did was just divide Vm over there. And then I know that's 1 plus B Vm plus C Vm squared, etc. So I'm starting to kind of see some similarities here. All right, and that's a good thing. But now in my Vanderwaal here, I'm factoring out an RT over Vm out of this whole equation. And as I said in our meeting today, the algebra is the hard part, you guys. You know the calculus. You're really good at the calculus. The algebra is what's nasty. So now trying to factor out an RT over Vm out of this thing becomes a little bit of a pain in the butt, but it's going to go like this. 1 over 1 minus b over Vm. And we know that this would work because if I distribute this RT over Vm back through, I'll have that first term. Okay, and then also that's going to be minus, okay, and then now if I'm factoring out an RT over Vm out of this thing, then that's going to end up looking like A over RT Vm, because I didn't have an RT in the first place, right? I did have one Vm that I could factor out, but I had to put this RT down below because now when I redistribute this back through, I'm going to get back that original expression. Okay, so now if I compare these two equations, they're starting to look really similar, right? So that's a good thing. We're getting somewhere. And now the whole idea, so if you look at this, focus this for 1 second here, okay, we're going to see Maclaurin again. So here is our general Maclaurin expansion, okay, et cetera, et cetera. 1 over 1 minus x equals 1 plus x squared, and so forth. And now if I look at this, okay, that's kind of looking like a Maclaurin, right? A Maclaurin series expansion. So here I'm going to call b over Vm equal to x, right? 1 over 1 minus x, 1 over 1 minus b over Vm, okay? And so now when I do that and expand this with Maclaurin, I know this is getting sloppy, apologies here, so we'll say p equals, I've got the RT over Vm. Okay, now don't worry about this term yet, okay? We're just going to deal with this term. And I'm going to expand this via Maclaurin. So now I know that the first term is going to be 1 plus x. Well, here I'm calling x b over Vm. Okay. And then now I've got a x squared, which I'll say is b squared over Vm squared. Okay. And I'm going to cut it off there. I'm not going to add any more expansion terms. And the reason why I'm not going to do that is because I can see here that I just cut it off at the square right here. So I'm just going to cut it off at the square right here. But now remember, okay, these three terms, right? 1 plus bm plus b squared over Vm squared. I got that from right here. Okay. Let me add some color. I'm probably just going to make this even more sloppy and illegible, but I'll try to make this, nope, wrong color. I'll try to make this a little more organized. So I'm going to circle this chunk, okay, right here. And this chunk corresponds to this chunk right here, okay? So I expanded that. I still have this term to go, okay? And I'm not going to do anything special with that. I'm just going to write it down. Let's see. Let's get rid of all those little dots. Okay. Great. So now I'm just going to write that directly, minus a over RT Vm. Okay. Great. So now what we can do from here, we can make life a little bit easier. For example, we recognize that z equals PVM divided by RT, all right? So let's get rid of all of that junk, okay? So if I rearrange this equation, okay, and multiply both sides by Vm and then divide both sides by RT, I'll have PVM over RT, and aha, look, that's just the compression factor Z. Okay, so now I'll say all that equals Z. And remember, so what I did to this, like I multiplied both sides by Vm, and I divided both sides by RT. So all that's gone, so now I just have Z equals 1 plus all this junk. But now let's combine some like terms. And I have a 1 over Vm, right? So I'll say 1 over Vm, and I factored that out of that b, okay? And I factor that out of that minus A over RT. Beautiful. And then now I just have this 1 plus B squared over VM squared. Okay? So, and that's my entire situation. And now, if you can figure out what the hell is going on with my notes here, we have it. Look, Z equals 1 plus 1 over Vm times B minus A over RT, the quantity, plus B squared over Vm squared. Check this magic out, you guys. Look, like I can rearrange this thing over here and I can do the same thing, right? Where I can say P Vm over RT, and we know all of that equals Z, just equals 1 plus B over Vm plus C over Vm squared. And look, compare this to this. You guys see it? Look, my 1 over Vm term, there's my B. So that means B has to equal little b minus A over RT. Also, that means C right here, right, has to be B squared. Fantastico. There it is, right? Q to the E to the mother D. Okay?